Just going to redo the last question and focus on the table. So let's quickly do it in Excel. So data analysis, and it is a two-factor without replication, and the input range is going to be all of this, and alpha is 5%. I did include labels. Output F1, is F1 good? Yeah, F1 looks good. Okay, let's put the answers in there. And so let's move down. So how do we get this table? Well, I want to replicate this table. So let me copy the table down. And what I'm going to do is I'm going to eliminate a bunch of numbers from it. So I'm going to delete all these. And let me just delete that one as well. So how do I fill this table in? Now, one of the things that I notice is that when we look at the PowerPoints, things aren't necessarily in the same order. So what are our rows? What was in our rows? Our rows had the 5 different blocks. So the rows are in fact the blocks. And what do we have in the columns? In the columns, what did we have? We had the 3 different blends, so we had the 3 different treatments. So for columns, I'm actually put columns / treatments. The reason I'm doing this is that it matches the wording we have over here. And you'll notice that treatments are in the first row, where they're over here in the second row. So you have to keep an eye out for that. If you're going to make a cheat sheet, you may want to put it in the order that Excel gives you the information in. You may want to flip these two over. But how do we find the degrees of freedom for the blocks? The blocks' degrees of freedom is the number of blocks minus 1. As we said, we've got 5 different cars, 5 different blocks. So 5 minus 1 is 4. And how about the columns, treatments, K minus 1, number of treatments minus 1. We have 3 different treatments. 3 minus 1 is going to be 2. And as you can see, I'm actually starting to replicate these numbers from the table above. And how do we find this degrees of freedom for the error term? Well, it's going to be the product of K minus 1 times B minus 1. So that's just the product of 4 times 2. So that's just going to be 4 times 2 is going to be 8, just the product of the ones above. And down here, the totals is just going to be the sum, or the total. And so it's going to be the sum of these guys. And again, 62 is replicating what we have above. And the sum, or the total here, is just going to be sum of those. And just remember that when we look at the total degrees of freedom, it's down here, it's 14. And if we add 1 to whatever the value is in here, just as with single factor ANOVA, it actually gives you the number of observations. We had 15 observations. And we had 3 different blends, 5 different cars. 3 times 5 is 15. So if I add 1 to this, I can figure that out. How do I find the mean square? The mean square is always going to be the sum of the squares divided by the degrees of freedom. It was replicating the number. So again, it's the sum of the squares divided by the degrees of freedom, replicating the 2.6. And again, it's going to be the sum of the squares divided by the degrees of freedom. So I'll replicate those numbers. Now, how about the F-test statistic? Be careful when you're coming up with this. The F-test statistic is a ratio, and it's going to have to divide 2 numbers. So the numbers we're going to divide is going to be the mean square for whatever it is we want to find the F-test statistic for, divided by the mean square of error. So it's not necessarily the one below. You always divide by the mean square of error to find the F-test statistic. And we've replicated the F-test statistic. So remember what I just said. To get the F-test statistic for the treatments, it's going to be the mean squared divided by the mean square of error. You always divide by the mean square of error. And again, we've replicated this number in here. And to get the p-value, we just use equals f dot dist dot right for the p-value. And so the first thing it wants is the test statistic. and then it wants the degrees of freedom that you used in generating the F-test statistic. And they were, in this case, they were the 4 and the 8, because we divided out by the error term. So that should give us the correct answer as the one above. And likewise again, if I want to find the p-value, is going to be f dot this dot right. So I'm going to use the test statistic, and then I have to use the degrees of freedom I used to generate that test statistic, which was the 2 and the 8, because I divided out the treatments mean square by the error mean square, and that gives me the same value as I have above. And f critical is going to be an f dot, let's do it, f dot im dot right. And so to get that, alpha was 0.05. Remember, if they don't tell you, just make the assumption that it's 5%. And again, you have to use the degrees of freedom that you used in generating this whole row, which is going to be the 4 and then the 8. And that's going to give us the 3.83. And likewise, for this one, we're going to use f dot inverse dot right. And the probability again is 0.05. The degrees of freedom are going to be this time 2 and 8, giving us that value we have above. So you should be able to use this to regenerate a table based on some basic information about the formation of the question. So you should be able to figure out the degrees of freedom by knowing the number of treatments and the number of blocks, and using your table, and then be able to maneuver all the way across the table.